Hello, y'all. Welcome to lesson 120 of my DP chemistry curriculum. Today we're doing the second half of structure 3.2.5. We're still doing IUPAC nomenclature, but now we're doing it for branch chains. So last time we did straight chains, now we're doing branch chains, focusing on monounsaturated compounds. And with those branch chains, we're also still going to be using those numeric prefixes. So when doing branch chains, we need to do a couple new things. But starting with the first, which is just generally what we do for all of them, we have to identify parent chain. That will still be the longest continuous chain of carbons, usually. On top of that, we need to identify side chains or branch chains. So those side chains or branch chains are going to be what gives this branch chain its name. Now, on top of those branch chains, we have a new naming convention. So we're still going to use the standard carbon names, numerical carbon names. And I mean meth, eth, prop, but, etc. But we're going to add the suffix ol. So that might be methyl, ethyl, propyl, etc. So that's how we know they're a branch. When we see methyl, ethyl, propyl, we know it's a branch to our original chain. Furthermore, if we have multiple, we still use prefixes for multiple. That could be di, tri, tetra, etc. So the last part of this is we are going to identify side chains with a number. So we have to say where they're coming off from with a number from parent chain. All right. So to do this, let's just start out with some easy alkanes. Help us get settled into this idea. So the way we're going to do this whole unit is mostly through examples. So just starting out, I'm going to use a skeletal formula. And we have this nice little structure. Now, we have a parent chain here. It'll be the longest chain. There are a couple options that we could look at. That could be a chain, that could be a chain, that could be a chain. So we have these three. We want to find the longest. Now, this one and this one are both the same length, so it doesn't really matter what we pick. I'm going to pick, going on the bottom, 1, 2, 3, 4. That is going to be my parent chain. I'll highlight it in yellow. With that as my parent chain, I see that I have one branch right here. It is just one carbon coming off the second carbon. This we can now name. So what we're going to do is we're going to start with our parent chain. I like to actually work from the middle out. So my parent chain has 1, 2, 3, 4. So it's going to be butane. Now attached to that butane, I have a single carbon group, and that is going to be methyl. Now that methyl comes off the second carbon, so it's 2-methylbutane. So I'm just going to go ahead and highlight relevant to what we're using in the diagram. So this is 2-methylbutane, that 2 referencing that 2 right there. That highlight color doesn't, there we go. That 2 representing that 2. So this is 2-methylbutane. It's not too difficult to see where that comes from. But once we start adding chains, we can have what we call structural isomers of the same thing. So this is going to be a structural isomer. Now, I'm going to go over structural isomers in the next video, but generally, this is the formula, or this is named for things with the same formula but different structure. All right, looking at our new one here, we have 1, 2, 3 carbons in a chain, or 1, 2, 3 carbons in a chain, or 1, 2, 3 carbons in a chain. No matter what, our longest chain is 3 carbons. So I'm going to go ahead and just color one of them. And on that chain, I have 2 methyl groups. So this is still going to be a propane. And looking at my numerical system, 1, 2, 3, these are both coming off 2. So I'm going to say 2, comma 2 dimethyl propane. And there it is. So the numbers come from where it's from. The methyls come from there, and the propane is the parent chain. And so this is how we start naming branch chains. We reference those alkyl groups that are the side chains, and then once we reference those alkyl groups, we just attach that to our parent chain or stem name. So with that, let's go ahead and try some harder examples. So in a harder example, let's go ahead and draw something pretty big. I'm going to pause it and come back once it's drawn. All right, so here we are with a much more complex branch chain. Now, you'll notice I've used a combination of ways of drawing this with condensed structural formula, but also full structural formula. You'll notice right here I put CH2 and CH3 just to avoid drawing everything. This is totally fine. You can do it yourself. Just make sure that your bonds still come out of carbons and everything has the right number of carbons and hydrogens. So with this, we have a couple weird chains. We have 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So no matter which way I see, I think my two longest chains are either this 6 or this 6. And so I'm going to end with a hexane. Now, with these two ones, we have two different options. I'm going to go for the zigzag right here. It doesn't really matter which one you go for, whether you go for that zigzag or like this. What I notice in both of these is that if I start numbering my carbons, 1, 2, 3, 4, 5, 6, or if I number backwards, I might have 1, 2, 3, 4, 5, 6. And this would work either way, whether I'm starting from here or going down. By numbering these carbons, I notice that my ethyl group, let's go ahead and highlight that. My ethyl group and my methyl group are either coming out of carbon 3 and 4 for the ethyl first, or 4 and 3 for the methyl first. So what do we do about priority? Now I'm going to go ahead and erase a lot of this just so things are a little clearer. I'm going to take away my numbers. When we do this, what you want to remember is that we're actually going to name these alphabetically. So priority for branches is alphabetical, meaning that ethyl before methyl. So I want my ethyl group to have the highest priority. So the best way to have it have the highest priority is number from the right. 1, 2, 3, 4, 5, and 6. With that number set, I can see that I'm ending with hexane. And now I'm going to go from my priority. So like we said, ethyl before methyl, this is going to be 3-ethyl. And then it's going to be 4-methyl. And it'll be hexane. If I go ahead and change the highlights here. We can make this a little more visible. My 4-methyl, my 3-ethyl, and my parent hexane. So this is how we start getting these names down. We have to start looking at priority for these, which for our branches, we're going to go alphabetical. Ethyl before methyl, and butyl before ethyl. Just remember your alphabet and you should be fine. Let's do another example. I'm not really going to pause it for this one. Just try and keep up the drawing. H3C, C, CH3, bonded to a hydrogen, and then from here, we'll attach that to a C, CH3 up here, CH2, CH3, C, that'll be a CH3, CH, H, CH3. All right, so there's a couple options, but I immediately see sticking out at me this parent chain containing 6 carbons again. This is going to be, or sorry, 5 carbons, not 6. And we have this chain right here giving us a um, methyl group and then an ethyl group. With that methyl group and ethyl group, we still have everything at a pretty low value. But the issue here is then we have another methyl group. So I can't actually take this chain. And so it starts becoming a bit of a puzzle. If I start here, then I have one methyl group. Whoops, let's use some different colors. One methyl group, two methyl group, and an ethyl group. This I can take. The problem with before is we had an ethyl group that had a methyl group on it, and the branch had a branch, and we don't really want any branches on branches. So you have to start trying to identify where these chains start and stop. So this is going to end with pentane, and that is that. Now remember, we want priority to be lowest on our ethyl, as that has the, or we want the numerical value to be lowest on ethyl. So we're going to count 1, 2, 3, 4, 5. Now the issue is that puts our methyls at 4 and 3. If we count the other way, 1, 2, 3, 4, 5, our ethyl group still stays on 3. So we can still start with 3 ethyl. But the difference is now our methyl group is on 2 and 3. And we prefer that because everything has a lower number, dimethyl. And the goal with this priority and numerical system that we have is to try and give everything the lowest possible numerical value they can, while ensuring that we give numerical priority to those that have higher naming priority. So in this case, ethyl, we want to get as low as possible. In both cases, it's a 3, and therefore we can go 3-ethyl, 2,3-dimethyl pentane. All right, so that is alkanes. What happens when we start adding double and triple bonds? So let's look at alkenes and alkynes. Well, turns out they're pretty much the same thing as alkanes. The only difference is that we're now going to try and give numbering priority to the ene or the ine. So if we have a branch, we want to try and give that branch the lowest value possible. So let's try some examples straight away. I'm going to be using skeletal formulas now, as I prefer them because they're faster to draw. So in this case, we need our parent chain to include that double bond, and that is the longest continuous chain we can have. I'll number these 1, 2, 3, 4, and we can just see that this is going to be 2-methyl but, but 1-ene. And therefore we have our double bond. Well, we have our bute here. We have our double bond, our 1-ene, and we have our methyl group on 2. So 2-methyl bute 1-ene. If we were to maybe change the configuration here to this, we still have our parent chain containing the double bond, and this is going to be now still 2-methyl. It could be 3 if we count backwards, but we want it to be lowest. Bute 2-ene. And that's from counting 1, 2, 3, 4. If I counted backwards, as in 1, 2, 3, 4, our methyl group instead would be on 3. But remember, we want the lowest values for everything. So just keeping things highlighted. Once again, 2-methyl bute 2-ene. Now, for priority, whenever that's in question, like we mentioned, we're going to try and give it to the ene or ine. So I'm going to start with a triple bond here. Then I'm going to go into maybe a hex carbon, but we'll put 2 methyl groups here. Or you know what, let's go even a little wilder. Let's make one of them an ethyl group. Regardless, we want our priority to be on the double bond, or double or triple bond. So in this case, I still have our hex 1-ine, hex 1-ine. I'm going to move it over. And now we have to name our groups. We are, of course, going to name the ethyl group first, followed by the methyl group. So this is going to be 3-ethyl, 3-methyl, hex 1-ine. And I'll go ahead and highlight the constituent parts. Methyl, hex 1-ine, and ethyl. So we can see them all referenced here in this diagram. Boop, boop, and boop. So that is alkenes and alkynes. Pretty quick section. Now the last one is functional groups. How do we start incorporating those? Well, let's take a look at an example of carbon, double bond to oxygen, single bond to oxygen hydrogen. That looks like a carboxylic acid with a CH3 and a CH3 and an H. So how do we go ahead and figure this one out? Well, we still want the parent chain. Parent chain has functional group, just like with alkenes and alkynes. So when I go ahead and I highlight my parent chain, it's this carbon, and then let's go up. It doesn't really matter which way we go. And we'll number them 1, 2, 3. So numbering starts from carboxyl. Now with this, we can just go ahead and start counting them out. It's going to be 2-methyl propanoic acid. That oic acid comes from the functional group of the carboxylic acid. The propan comes from our 3 single bonded carbons, and the methyl comes from that 1 methyl group off to the side. And that's it for functional groups. Now, the only time it gets hard is when we start having multiple chains. So let's go ahead and look at that, multiple chains with different priorities. So the first thing we want to know is that we generally want functional group to have highest priority. There is an exception, priority. There's an exception to this, and I will go over it in a moment. But when our functional group has the highest priority, let's look at a new compound. We'll have a C double bond O, so that's a carbonyl group. More specifically, that is a ketone. We'll put a chain there, put a chain here, and now we're looking for the longest chain that contains the ketone. So with that in mind, we should start from over here so that we know we have our ketone in our chain. Now, regardless of if I go up or to the right, it truly doesn't matter. So I'm just going to go ahead and move to the right and down. This is going to be a 1, 2, 3, 4, 5, ensuring that our ketone has the lowest priority. With that in mind, we have an ethyl group here on carbon 3. So I'm going to start with 3-ethyl, and then just naming our 5-carbon group, propan 2-one. And that's it. Our propan comes from the 5 carbons, our 2-one comes from the ketone, and our 3-ethyl comes from that ethyl group. Priority still going to the functional group. All right, so priority will start getting a little more complicated as you do more organic chem. So let's talk about mono unsaturated compounds. That's all you'll really see in the DP when you have a lot of different priorities going on. A monounsaturated compound is just a compound that has one CC double bond, and that's always going to, or usually, lower priority than functional group. So that's going to be something that has functional groups, maybe one, maybe two, maybe three functional groups, and a double bond. And that double bond will usually have the lowest priority. I say usually because it's not always true. Now, for the DP curriculum, we have a ranking of a priority for DP. This must be memorized. You need to know this. So figure out however you want, but it is carboxyl is number one priority. Following the carboxyl, we have the carbonyls. So think about big group, then double bond oxygen, then single bond oxygen going to hydroxyl. Then we have our alkene. And then at the bottom of the totem pole, we have halogenoalkanes. Now you may say, well, what if I have one of my two carbonyls or both carbonyls? What gets the highest priority? Aldehyde, then ketone. You can think about aldehydes being at the end, so they should always be number one. That's kind of why you think of carboxyl always having higher priority. It's at the end, it's got some double bonds, it's a big hulking thing at the end that gives a lot of chemical properties. It's just kind of the most important thing there. So let's look at an example of a monounsaturated compound, and we'll do 2 or 3 examples and then call it a day. So let's start with some double bond, single bond, OH. So in this case, 1, 2, 3 carbons. This is a propene. And with that propene, we have a single bond to an OH, a hydroxyl group. Hydroxyl is going to take the priority because I see that it's above alkenes. So that'll be carbon 1, carbon 2, carbon 3. So I will name this prop 2-ene, and I won't put that last E. Instead, I'm going to do in 1 all. Prop 2-ene 1 all. And that's how we name these compounds. It gets more and more complicated as we add more things, but you'll get used to just putting it together as a puzzle more than trying to solve names. Like, for example, if I threw another OH here, it would be prop2ene 1,1-diol. And we're just adding that in. You can just shove all these puzzle pieces together. Even if it sounds weird, it's still probably right. Let's do another example. H2C, single bond C, or double bond C, H, C, O, OH. Pause it, try and figure this out, remembering where priority goes. All right, I'm going to go through this now. Still a propane, but actually it's a propene. But remember, carboxylic acid gets that priority, 1, 2, 3. So you may have named this prop2-enoic acid. And while that seems right, it actually isn't. If you notice, when we look at this, the carboxylic acid has 1, 2, 3 bonds, meaning this cannot be a double bond. So for a 3-carbon alkene with a carboxylic group, there's only one possible answer. It's propenoic acid. So you need to be careful sometimes because many of these groups, there may only be one configuration. And when there's only one configuration, especially for smaller organic compounds, you don't need to add the numbers because there's literally no other way to create this compound. So this is propenoic acid. Now, let's try something with multiple functional groups. For this last example, let's try something. We'll do skeletal formula. Let's do OH, I, Cl. At this point, you may want to pause the video and try it yourself. All right, so let's go ahead and solve this one. So first off, I'm going to go ahead and note what the priority is at. I see a hydroxy group, which takes priority over our alkene and our halogenoalkane. So I'm going to go ahead and start my numbering system, putting my hydroxy at the lowest. All right. With this, I'm going to go ahead and now start naming each group from order of where they'll appear. Now, I notice that I have some halogenoalkanes, so they are prefixes, so I may start from them. Now, we have our first halogenoalkane coming out of 3 and our second one coming out of 2, keeping with alphabetical order. So I'm going to start with 3-chloro. Then I'm going to shift over to 2-iodo. And that gets my halogenoalkanes out of the way. So let's go and highlight those. Following my halogenoalkanes, I don't have any more prefixes here. The rest are going to be inside our group. So I must now identify how big my chain is. It is 5. So I can say 3-chloro, 2-iodo, pent, and now I have to add my double bond right here. Oops, thought I was on my highlighter tool. My double bond is between carbon 3 and 4. So we'll say pent 3-ene. Go ahead and highlight that. Pent 3-ene. And then lastly, I have my hydroxy group, my alcohol, chilling at the end with the highest priority, 2-ol. And this is how we name a larger compound. Take it step by step, just go through the parts, make sure that you find your highest priority and make your numbering from there. And once you have your number set on your parent chain, you can work out the rest. So once again, this is 3-chloro, 2-iodo, pent 3-ene 2-ol. And that is it. If you can solve this no problem, then this is about as hard as it will get for the DP exam. So I hope this helps and have a great day.